Hello guys, welcome to the session. Today we are going to discuss some problems for IIT JEE and NEET exams. The topic we picked up today is electrochemistry. Okay, we have already we have had a session already on this electrochemistry, right? We have discussed around 7-8 problems there, JEE level problems, subjective questions we are discussing. You see, there is no option over here, right? So these are the questions of IIT JEE, but it is not like it is only useful for those kids who are preparing for IIT JEE. Okay, concept you must understand. Okay, it helps you in other competitive exams also, right? Fine. So look at this question, question number 9. The standard reduction potential is given for AG, right? KSP is given for AGI. Evaluate the potential of AG plus to AG electrode in a saturated solution of AGI. Also find the standard reduction potential of this electrode. Okay, you can pause the video and you can try this on your own. Okay, I am continuing with the solution over here. Okay, so you see the electrode potential of AG plus to AG, it is given, that is 0.799. AGI KSP value is given. So when we have this saturated solution of AGI, right? So the saturated solution of AGI, the half cell reactions are, what are the half cell reactions? We have AG electrode and AGI saturated in the solution. So first reaction is the conversion of AGI into silver plus I minus. This is reduction reaction, cathode, and the silver is getting oxidized. This is the reaction at anode. Right? So overall, the reaction is what we can add the two and we can find out the E value of this. Okay. Since KSP of AGI is given, right? So we can find out the AG plus concentration. AGI is given, that is the concentration of AG plus into the concentration of I minus. So concentration of AG plus the square is equals to, because both will be equal, AGI dissociates as AG plus plus I minus, so concentration of both will be equal, right? So this is equals to 8.7 into 10 to the power minus 70, right? So when you solve this, you'll get AG plus concentration as, calculate this root over of it. So that is around, again, we'll get, okay, 9.3 root over of it, and this is 10 to the power minus 9. This is the AG plus concentration we get. Okay. Now the standard reduction potential of AG plus to AG is given. We need to find out electrode potential of this. So we can write down the Nernst equation for this, which is E of AG plus to AG is equals to E naught of AG plus to AG minus 0.0591 by 1 log of 1 by AG plus. So now we can substitute the value of E naught of AG plus and AG plus here. We'll get the answer. So E naught of Ag plus is 0.799 minus 0.0591 by 1 log of 1 by 9.3 into 10 to the power minus 9. You can solve this. You'll get the electrode potential for Ag plus to Ag is approximately 0.324 volt. Okay. This is the first part of this question. Ag plus to Ag electrode in a saturated solution, electrode potential is 0.324 volt. Also find the standard reduction potential of this electrode, I minus, AgI and Ag. Okay. Fine. The cell that we have, right? This cell, standard reduction potential of this we need to find out. Okay. So this means what? The reaction, if you consider here, we have AgI saturated. So for this cell, the E naught cell will be because E cell is 0, so it is 0.0591 log KSP. KSP of what? AgI. So we know all these values. When you substitute, you will get 0.0591 log of KSP is 8.7 into 10 to the power minus 70. So when you solve this, you'll get minus 0.954. This is the E naught cell of this. Now, you see this E naught cell is equals to what we can write further, because we need to find out for okay. So here you see, we need to find out the standard reduction potential of this electrode, right? I minus to I plus and Ag plus to Ag, right? Ag plus to Ag and I minus to I plus we have. Okay. So the E naught cell for this, E naught cell for this one will be the E naught of cathode, E naught of cathode minus E naught of anode. Both are reduction potential. So E naught cell we have calculated, and Anode is what? Anode is silver electrode, because this is saturated in Ag solution. So this is one electrode and this is another electrode, right? This is one electrode and this is another electrode. So here you see E naught of cathode, anode is Ag plus we have. So E naught of cathode is equals to minus of 0.95 plus, for Ag plus it is 0.799 reduction potential. So when you solve this, you'll get negative of 0.151 volt. So this is the answer we have. So we have two answer. One is this and another one is this. Okay. Reduction potential E value is this. Standard reduction potential of E cathode is this, right? So we need to find out, we have actually two electrode. One electrode is Ag plus 2 Ag and another electrode is this, I minus 2 Ag, I 2 Ag. Means silver is present in a solution in which is saturated with AgI. Okay. One behaves as cathode, other one behaves as anode. The reduction potential of Ag plus is given. For AgI, Ksp is given. Right? So we have calculated the reduction potential of standard reduction potential of this one, right? AgI that we have here. The overall cell reaction is this. Overall cell reaction, how do we get? When we add these two, right? So cathode is this, it is given here. So cathode is nothing but this, which is this cell reaction. So this is here, is the cathode. That's why we'll write this. And E naught cathode is nothing but this. Okay, that is the answer for this question. Okay. Next question you see. You see, there's a storage cell. Edison storage cell is represented by this. It is given. Half reactions are also given. Okay, Ni2O3 plus H2O gives this. E naught value is given for both, and both are reduction reaction. If you observe this, both are reduction reaction, and hence the potential that is given, that is the reduction potential. So what we can conclude from this, since the electron is getting consumed here, so both are RPs, reduction potential. This is also reduction potential. So the one which has more reduction potential will get reduced. Okay, so cathode is this reduction. Okay, I'll write down here only. This is cathode. Obviously, it is the right side, so it is cathode. Left side, so it is anode. Right side cathode, left side anode. Okay, so cell reaction will be what? We'll have to add the two reaction. Right, we have to add the two reaction. So what we'll do, we'll inverse the second one and we'll add with 2. Right, we'll inverse the second one and we'll add with 2. So cell reaction is here. Cell reaction is, we'll inverse the 2 and add with the first one. So I'm writing it down directly. Fe solid plus Ni2O3 solid, H2O an electron gets cancelled. Right hand side we have 2 NiO solid plus FeO solid. Okay, this is the cell reaction. So first one we have done, A. B is what? B is what is the EMF of the cell? How does it depend on the concentration of KOH? So EMF of the cell is what? E cell. Again, we'll use Nernst equation is equals to E naught of the cell minus 0.0591 by 2 log of NiO square FeO divided by Fe and Ni2O3. I think this should be right. All these are given solid. So this thing is 1. We can write this entire thing as 1 because all given as solid here. Right? So directly we can substitute here. E naught of the cell is what? E cathode minus E anode. So E cathode is this. That is 0.40 minus E anode is this. That is minus of 0.87. Minus 0.0591 divided by 2. Log 1. So log 1 is 0. So answer for this question is the sum of these two, which is 1.27. Right? Now the OH minus concentration that we have here, it gets cancelled, right? It is not present in this expression. There is no OH present here. Hence what we can write, the second part of this, the E cell is independent of KOH concentration. This is the second part of this question. Okay, so this is the another answer we have. Now the last one is C. What is the maximum amount of energy that can be obtained from 1 mole of Ni2O3? Okay, so 1 mole of Ni2O3, the energy is what? The energy is nothing but the delta G. But we have to talk about the magnitude here. NF E cell, right? Since maximum amount of energy has been asked, so it must be E naught cell. We won't take EMF. EMF is this E cell. E naught cell, if you take, when it has 100% efficiency, all these E naught cell converts into energy, then we'll get the maximum energy, right? That's why we have taken E naught, not E cell here. So we'll substitute 2 into 96500 into 1.27, the E naught cell, which is 245.11 kilo. So this is the answer for the third question. Okay, so I hope all of you understood this. Okay, easier one.